Welcome to homework.
Here the question is, identify the lettered intermediates in the following reaction scheme. This is an alternative method to synthesize amino acids based on Gabriel synthesis of primary amines. So, Gabriel synthesis of for the preparation of primary amines is used actually here for the preparation of amino acids, and the starting compound here is malonic ester. So this is malonic ester, ethyl ester. This compound is malonic ester. And in case of malonic ester, we know one thing, that one hydrogen which is present in between these two carboxylic acid groups is actually acidic, and it can be substituted easily by bromination. So a compound should be at least one hydrogen is replaced by bromine. So this compound must be A, ETO, C double bond O, CH, C double bond O, OET, ethyl ester. And one hydrogen is replaced by bromine. So this should be a compound. Now what happens in the next step, it is treated with thelimite, and in the thelimite also this nitrogen containing hydrogen is acidic, and we are taking the potassium salt of this thelimite, and by this the compound B is formed. So B compound must be at one side we have ETO, which is directly attached to carbonyl group, and then it is attached to CH, and then again it is attached to carbonyl group, and so ethyl ester, OET must be here. And one hydrogen of which is bromine was present here. So with this potassium thelimite, potassium bromide is formed, and this should directly attach to nitrogen. So the compound should be nitrogen, which is further attached to two carbonyl groups, and that is directly attached to benzene ring. So benzene ring must be here. This is the thelimide structure, and at the nitrogen joining is taking place with the carbon of the diethylmalonate. So this should be the structure B. Now structure C is alkylation is taking place, and first step is reaction with sodium ethoxide. So alkylation when taking place, that means the second hydrogen which is present in between two carbonyl group should be replaced by the alkyl group. So C compound should be other part will remain same, ethoxy group, then carbonyl group, then one carbon, then again carbonyl group, and one OET, ethyl group. So this is this part is not needed, so we can remove this here, and only ET will be here. Now after this, here this nitrogen group, that means the thalamide part, is not disturbed. So double bond O, double bond O will remain same. Then two bonds here which are joining with the benzene ring. So in case of thalamide, it should be benzene ring here. So this thalamide part will remain intact at this step, and the hydrogen which is present here is actually replaced by alkyl group. So now the alkyl group must be, according to the second step, alkyl halide which is taken. So it should be attached to CH2, then again CH2, and then SCH3. CH3. This whole side chain, that is the R group, is attached to this carbon atom. And this should be the structure of C. Now in the next step, reaction with NaOH, water, H3O plus and heating. This all is indicating that the final amino acid is formed, and decarboxylation or hydrolysis and all these steps are taking place, and D is formed. So D compound must be amino acid. So it should be at this carbon atom, at one end it should have CH2, CH2, SCH3. This whole imide is giving the NH3 plus, because the medium is acidic, so we are not getting the free amino group here. In place of that, this one protonated amino group we are getting, and carboxylic acid group will remain here, one carboxylic acid, and by decarboxylation of the other part, only hydrogen is left over here. So this should be the structure of D. And this amino acid is methionine. This is the amino acid formed starting from this diethylmalonate. And these are the structures of A, B, C, and D compound. So this is the final D compound.